Hey, Uniteds, hope you had a great break and welcome back to term 4 and another episode of math class. Today we're going to continue on with where we left off last term with trigonometry. So if you didn't see the post below, that was the intro lesson on what trigonometry is. Today we're going to use trigonometry and the concepts we learned in the previous lesson to actually find out the missing side lengths of right angle triangles using the trigonometric process. Right, without further ado, let's calibrate our calculators. The first part you need to solve in trig is either a really big brain or a sufficiently calibrated scientific calculator. So if you press on your calculator, hopefully on the top row of random words and symbols and letters, you've got the 3 letters DEG, DEG, or in short for degrees. If you see that you've got RAD, your calculator isn't calibrated in the right settings. So if you have RAD, that means you're in radians, okay? If you are in radians, what you want to do is, I wish I had your calculators in front of me, but press second or shift, depending on which sort of calculator you have. Once you press second or shift on your calculator, click on either mode or, click on mode, and there should be a way to change from radians back to degrees, okay? It should be under scientific, but all the calculators are slightly different. If your calculator doesn't say degrees and you can't change it, can you please see if your siblings or parents have another calculator? Alternatively, you could try and Google for a scientific calculator with the degrees setting. If your calculator is on degrees, great. Let's just double check you have the right settings just in case, because if you don't, you will do this entire chapter incorrectly. So how do we check? Let's do sine 50, or abbreviated as sin 50. Sin is short for sine, S-I-N-E, that we mentioned back in exercise 3E. Type that in. So on your calculator, there should be a sin button. Press that button, type in 50 straight after, shut the brackets. You should get 0.77. What do these numbers mean? We'll investigate later on. But for now, just let's check that we've got these numbers. The second one we have cos 16, shut the brackets. So find cos, which is short for cosine. Press that button, type in 16, shut the brackets, and you should get 0.96. Keep in mind, we are going to 2 decimal places, so that's why I'm cutting the decimal places short. And then lastly, we have tangent 77, or in short, tan 77. So find your tan button, press that, type in 77, shut the brackets. You should get 4.33. Right, what does this all mean? If you care to ask, or if you're curious, I'll tell you back at school so I can diagram it a bit better on the whiteboard. But for now, if you've got these numbers, your calculators are in the right space and in the right setting, so we can proceed to do trigonometry. If they're not in the right setting, see if you've got a spare calculator somewhere and see if that's in degrees. If you can't change it, and check with a friend or Google if you have no other calculators that has the degree setting. They should all have the degree setting. It's just a matter of fiddling around. But let's get to it, assuming that you've got the right settings. How do we use trigonometry to find missing side lengths? So what we have here is previous exercise. We had these side lengths all filled out, nice and easy. We wrote a trigonomic ratio. We're like, ta-da, we picked the right trig ratio, which is sine, cos, or tan. Building off that, the next step is, well, what happens when they don't give us one of the side lengths? So here they give us 7 and 38 degrees, but then they tell us to find this missing side length, x. And the first step you always need to do, all right, so step 1. That sucks. Let's try and make that a little neater. Step 1, label given sides. What does given sides mean? Well, we're given the sides x and 7. We're not given this side down below the 38 degrees. So we don't need to label this side. Why? That's really important because you won't be able to choose the right ratio. All right, but before we get into that, let's just label the sides. What's this 7 side called? It's the longest side. Starts with H, ends in hypotenuse. If you guessed hypotenuse, you are spot on. We've got the hypotenuse on the 7 side. The hypotenuse is always the longest side, but what's this side here called? This x side. Any ideas? From memory, I think we used red. This x side is furthest from the degree that's given, and that's always going to be the opposite. Okay, the opposite is always the further side from the degree. So it's not touching this degree in here. So see how this side here is touching that we're not labeling? The opposite is the furthest from that degree, so we call that the opposite. So we've labeled the given sides. Okay, so we've got opposite and hypotenuse. Now we can proceed to step 2. Step 2. Pick SOHCAHTOA based on your labels. What is that? Right. So, well, how do we pick SOHCAH or TOA? You look at the last 2 letters. So in SO, we look at O and H. In CAH, we look at A and H. In TOA, we look at O and A. Which one has O and H in the abbreviation? Is it sine? Is it cos? Or is it the tangent ratios? Or is it, in other words, SO or CAH or TOA? What you notice here is we have opposite and we have the hypotenuse. So notice how we labeled the hypotenuse and opposite. So this means to figure out x, we need to use the sine ratio. So we pick this. This one. Right, now what we have to do is step 3. So that's step 1, step 2, step 3. Right ratio. That's ration. Right ratio and substitute values in. So we know the sine ratio always compares the opposite side divided by the hypotenuse side, or the opposite side compared to the hypotenuse side. So what we do here is with this ratio, or this abbreviation SO, we go and say, well, sine theta equals the opposite, which we had in red, on the hypotenuse. And so looking at our triangle, what's our angle? So we carry this down, still write this as sine, or if you want to call it sin, go for it. What angle are we given? Remember, the theta just means angle. We're given 38. Okay, so the 38 came from this angle above. What about the opposite? What's the opposite angle here? Or sorry, the opposite side length. The opposite side length is x. We don't know. So we replace the O with an x. And what about the hypotenuse? What value is a hypotenuse? If you answered with 7, you are spot on. Where did the marker go? There it is. 7. So what we've done now is we've substituted the values of the given triangle into the ratio that we picked, okay, based on what the information that we're given to us. And now comes the slightly tricky bit. What the heck? Oh, here we go. Using linear equations, how do we get x by itself here? Step 4. Let's use red. Get x by itself. How do we get x by itself when there's a 7 below it that's dividing it? So here we've got x divided by 7. How do we get rid of the 7? What's the opposite of divide? If you said the opposite of divide is multiply, well, you are correct. We multiply the left side by 7. So to neutralize the division by 7, we chuck the 7 to the other side and we times sine 38 by 7, or sin 38 by 7, depending on how you want to remember sin or sine as. So here we've got sine 38. Now the 7 gets chucked to the other side, but instead of dividing, we have a multiplication. And now on the right side of the equation, the x is by itself. All right, if you'd like the proof, please email through. I'm gladly to explain the linear equations behind it. But sine 38 times 7 is pretty confusing. We don't know what that means. Okay, like what sort of length is that? To find this length, either calculate it in your head or use your calculator, hopefully that you've calibrated. So I don't think anyone's going to take the head calculation route, but press sin or sine, type in 38, shut the brackets, really important, you shut the brackets, times 7, press answer or equal, however your calculator's calibrated, whatever setting it's in, and you should get 4.31 as your answer to x. All right, 4.31 is this value here. Usually they'll tell us centimeters, meters, kilometers. Unfortunately here they didn't give us a unit, which is pretty clumsy of Cambridge. But that's the answer for the first one. Now, the second example, it's the exact same steps. All right, for this whole exercise, it's the exact same steps. I'm not going to write the steps. You can refer to above if you would like reference to the steps, but I will verbally explain what I'm doing. So here, example B, Who remembers what the first step is? The first step is to label the given sides. So what side is this 4 side called? Is it the longer side? No, the longer side is the hypotenuse, which doesn't have a value for us to figure out. So that's not given to us, so we don't care about the hypotenuse here. So what's this 4 side here? It's touching the angle. So this edge of 4 is touching the angle. The side that's touching the angle is called the adjacent. Apologies to those who've got it ages ago. I'm just trying to stimulate some thought. What about this x side? Furthest from the angle, but it's not the longer side because the longer side is always opposite to the right angle. So the right angle's here, and the opposite angle to the right angle is always the hypotenuse. So we know x isn't the hypotenuse, it's not the adjacent, it must be the opposite. So from there, we write out our abbreviation. Well, is it an abbreviation? No, it's an acronym, isn't it? Write out our acronym, our ratio acronym, and we look at the last 2 letters of each ratio. So sines ratio of opposite divided by hypotenuse, is that the one that we're going to be using? No, because we don't have a hypotenuse side. Are we going to be using cos or cosine? Are we going to be using cosine with adjacent and hypotenuse? Well, we've got the adjacent, but we don't have the hypotenuse. So that leaves us with the tangent, or tan. Are we going to use a tangent ratio? Yes. Why? Because we have an O. We have an A. So what that means is tangent, you are going to be our ratio that's going to help us to figure out this missing side length called x. So we write our tangent formula, which goes like this. Tan theta equals the opposite divided by the adjacent. What is the opposite divided by the adjacent? Well, we have to sub in our values first. So tan theta becomes, well, the angle inside is 42. So we replace theta with 42. The opposite value is x, so we replace the O with x. The adjacent value is 4, so we replace the A value with 4. Now our game is to get x by itself on the right side. So if x is divided by 4 on the right side, how do we get rid of this division of 4? Well, the opposite or the inverse of division is multiplication. And what we do is we throw that 4 to the other side, which is the left side here of the equation, and we turn that into a times 4. Okay, using what we learnt back in linear equations. And this here is going to tell us our x value or our x length on this side. So using our calculators, press tan, type in 42, shut the brackets. Okay, actually some calculators don't have the brackets. So again, I wish we were in class for this. If your calculator proceeds by showing tan and then an open brackets, that means you need to shut the brackets. But if your calculator doesn't show brackets, maybe you can get away with not putting the brackets. But even if your calculator doesn't show the brackets, okay, make sure you punch in an open bracket like so. Okay, so if you press tan and there's no open bracket, punch in an open bracket by pressing the open bracket button, type in 42, shut the bracket, and then multiply it by 4. All right, what you should get is 3.6 or 3.60. But 3.6 will do because the 0 is insignificant, and that is going to be our x value. All right, so what we have here is 2 examples. Let's take a look at the third example. So what we have is a third triangle. The steps are the exact same. So if you go back to example 1, you can write these steps in for each one of these if you like, if that helps. But I'm not gonna do that for every single one because it'll be super tedious. And eventually you guys won't need the steps yourself to figuring out these questions. Right, what we have is 2 sides, tan and x, with an angle of 24 degrees. What are these sides called? What's the tan side called? It's the longer side because it's opposite the 90-degree right angle. So this is our hypotenuse. All right, the x side here is one of the shorter sides, and it's touching the angle. All right, so it's next to the angle, which means it's the adjacent, because adjacent means next to the angle. So we've got hypotenuse and adjacent that's given to us. Okay, again, we don't label the blank side because that's not given to us. So out of sine or so, cos or car, and TOA, which one of these acronyms have adjacent and hypotenuse in them? Is it the sine ratio, opposite and hypotenuse? No, we don't use the sine ratio because we don't have the opposite. Is it the cos ratio where we have the adjacent and hypotenuse? Yes, it is the cos ratio because we have the adjacent and we have the hypotenuse. So what we do is we circle this cos ratio and we say, well, therefore cos theta is the adjacent side. Notice how adjacent comes before hypotenuse. Adjacent side, hypotenuse was in blue, wasn't it? The adjacent side divided by the hypotenuse side. Right, and what we do then is, well, this generic formula is no good to us unless we put values in. So we say, therefore, the angle replaces theta. Microsoft Word has stopped working. Nuts. Oh, good, man. It's like nothing happened at all. Again, this is all very unedited. There's everything you see is what I see and encounter. So the angle inside is 24 degrees. We replace the theta with 24. We replace the adjacent side with x because that's the value, the unknown value. And we replace the h with 10 because that's the hypotenuse side length. From here, well, we ask ourselves again, how do we get rid of this 10 so x is by itself on the right side? Well, the opposite of division is, remember these symbols of 3 dots just means therefore. Therefore, cos 24 will become multiplied with 10 because the opposite of divide by 10 is multiplied by 10. And we chuck this to the left side. And so the right side is going to be just X now. And I'm sure people are going to be triggered by this blue equal sign, so I'll just keep it consistent. There we go. And last step, type in the left side of the equation into your calculator. Press cos 24, shut the brackets, times 10, and that will get us 9.14. All right, so 9.14 equals the adjacent side, which is called X in our scenario, and that length there is 9.14. Whatever units they want it to be. Okay, so that's literally it for exercise 3F in the old textbook. Have a go at question 5. In the new textbook, this should be your question 3. I have a feeling. All right, but just look for this set of questions. Okay. Please do all of it and make sure you show all your working, because on a test you can get consequential marks, which means if you get the final answer wrong but you've done the right working out process, you still get most of the marks. That's all for today. Thanks everyone for listening. Have a great day.